Good afternoon, everyone. Good afternoon, everyone. Hi. Thank you for being here. I will try to speak slowly again for those non-English speakers. I want to mention a couple things. First off, the end of the day at 5:30, we're doing a roundtable discussion with a good group of people, and we're looking for your feedback to get the questions to them. And we will curate the questions a bit, so if there's redundancy, we won't make it redundant. That's the URL for the Google Docs spreadsheet form that you can fill out. Please feel free while you're doing this to ask to write down questions for Douglas while he's talking. He is going to take a few questions at the end, and then he'll be in the panel as well, as are a lot of other people. And in general, we'll have an interesting debate with some really intelligent people in the JavaScript community at the end of the day. So please do that. So let me tell you a little bit about myself. My name's Lyle. I'm Lyle at Twitter and other places online. And I started from electronics and stepped into web development as the web development became something that you could do. And self-taught everything. Unfortunately, too much time in Perl, and not enough time in JavaScript. And I think one of the reasons I never really spent a lot of time in JavaScript, of course, is the browsers, as we all had problems with early on, and not being a server-side solution really early on. But you know, I picked up that wonderful O'Reilly book, JavaScript: The Definitive Guide, which is the current version, 6th edition, is 1,000 pages long. It's like this big, right? And I flipped open, as all of you did, trying to step from the copying script that you might have saw somewhere, or the Pascal class, and trying to translate that knowledge into JavaScript, and kind of getting stuck and feeling a little lost. And that felt like that for years. And I would argue that the reason why, one of the major reasons why JavaScript is at the state it's at right now, is because of this man over here, writing his definitive book, which of course, JavaScript: The Good Parts. And if you don't have that book, shame on you. Get it. It's fantastic. Because what it does, as does JS.Lint, which is of his library as well, to hone JavaScript, is to pull out the rest of that 1,000-page volume of junk, the bad parts. And having that kind of clear, let's start with this, and now let's debate after that, has given us a platform, I think, in this community to be able to have a dialogue that's intelligent and moves us forward. So Douglas Crockford, of course, an author, programmer, and worked at Atari, Lucasfilm, Paramount, Yahoo. He discovered the JSON data format. Now, I like that you say you discovered it, because, of course, that's a very scientific way of saying it. So thank you for doing that, but also, yay, JSON, right? Thanks, Douglas. So, Douglas Crockford, thank you so much for being here. Please.
Bonjour. Okay, so I'm going to be talking about JavaScript, and chronicling its rise to power. And you may learn a few things you don't know about it, although you probably already know a lot about it. So JavaScript has become the world's most popular programming language. There are more people writing in JavaScript today than in any other language. Now, you could argue most of those people should not be writing in any language. And you'd probably be right, but in fact, JavaScript is a language they're writing in. Now, at the same time, JavaScript is the world's most unpopular programming language. If you took a survey of any group of programmers and asked them, what language do you hate the most? By far, the most common answer is going to be JavaScript. And it's amazing that JavaScript can be the most popular and the least popular language at the same time. Part of the reason for its unpopularity, at least among the people who use it, is that it is the language that people use without bothering to learn it first, which is not a mistake you would make in any other language. But for some reason, people feel good about being ignorant about JavaScript and literally not knowing what they're doing. It's very common when you hear, seasoned, supposedly professional programmers saying, okay, I'll write in JavaScript because that's where the jobs are going. I'd rather be working in a manly language, but I'll write in JavaScript. But there's no way I'm going to know what I'm doing. That's principle. They feel there's a principle there in being ignorant, which is nuts. So let's start looking at history. So in 1995, Java applets were posed to take over the world. It was the biggest phenomenon ever seen in the development of software. Java applets were everywhere. We used to have places back then called bookstores. And you could go into a bookstore and you could find shelves and shelves and shelves of books about Java. And it was taking off. And then it failed. It fell flat on its face, the biggest failure in the history of software. The Java community doesn't like to talk a lot about that, but in fact it did. Yeah, huge. So about the same time, there was a startup in California called Netscape that spun out of the University of Illinois, and they were making what was going to be the first commercial-grade web browser. And they decided they wanted it to have functionality similar to Apple's HyperCard product, which was something that had made Macintosh programming much easier in the early days of the Macintosh. And they put this guy to work on it. This is Brendan Eich. Really, really smart guy, but had no experience with HyperCard, no experience with scripting language, or really with the web. And they tasked him with, they gave him a copy of Danny Goodman's JavaScript, or not JavaScript, a HyperCard Bible, and say, make it like that. And they gave him 10 days to do it, which is an insanely short amount of time to design a whole new programming language and implement it and all the stuff that goes with it. He's an incredibly gifted guy and managed to do it, but as you would expect, you make a lot of mistakes if that's as much time as you have. So the working title of the project was Mocha, sort of a coffee-flavored thing. So he took elements from Java. He took syntax. In fact, most of the bad parts in JavaScript came from that. He took functions as first-class objects with lexical closure from Scheme, which is the best idea in the history of programming languages. They've been doing this stuff with Scheme at MIT forever, but it never got into the mainstream because MIT put it in S-expression syntax, and the mainstream hates that because they don't like to count parentheses. The first language to take lambdas properly scoped and take it to the mainstream was JavaScript. And it was really audacious that Brendan was supposed to be designing a language for beginners, and he went and put lambdas in it and didn't tell anybody. Just amazing. Then he went to another research language, Self, which was the next evolution or the next step in the evolution of Smalltalk. Self took the really dramatic step of taking classes out of Smalltalk and improving the language by doing that. The language became much more expressive, and they were able to make it go much faster, lots of benefits. So it's the origin of prototypal programming. Brendan put that into this language too. So he took features from two well-regarded but not popular research languages, put them into a language for beginners. Just astonishing. And the interaction of those two features is amazing. Once you master functions, once you master prototypes, this language just becomes incredibly powerful. And it was called LiveScript. Sun Microsystems, which was driving Java, decided that they needed to align with Netscape because they were both claiming to have platforms which were going to destroy Microsoft. And they figured they'd better work together because if they worked against each other, Microsoft would play them off against each other and they'd both lose. So they formed an alliance, and the first thing they agreed on was that Netscape should put Java into their browser, which they did. And step two, kill LiveScript, because at the time, Sun was saying that Java was the last language anyone was ever going to need, so it was an embarrassment to have this other language in the browser. So kill it. And Netscape didn't, for two reasons. One, they didn't have time, because they had this primitive DOM, which only knew how to talk to LiveScript, and it didn't know how to talk to Java. So they had a bridge called LiveConnect, which allowed Java to talk to LiveScript, and then it could talk to the DOM. And if they took LiveScript out, then Java could not interact with the browser, and that would look stupid. But the other reason was they wanted a language for beginners. That was really important to them. And Java is not that language. You need to have a lot of knowledge about Java to write Hello World. It's not something that beginners can do. So they were at an impasse when Mark Andreessen, one of the founders of Netscape, maybe as a joke, suggested that they change the name to JavaScript and that they position it as Java's stupid little brother. It's interpreted Java, which is silly because Java is interpreted Java. It's a completely different language, but it happens to have the same name. And this has been incredibly confusing. Now, Microsoft took notice that there were these two companies in California that were getting ready to destroy it. So they decided they needed to get a browser too. They had completely missed the web. They thought the next step in the future of telecommunications was going to be fax. So they went out and bought a web browser and got into the game. And they decided that they needed to do something about JavaScript too. So they put a team on reverse engineering it. And they did the best job of reverse engineering ever in the history of Microsoft. They found every error, every mistake, every design defect that Brendan made in those 10 days, carefully described them and cataloged them and replicated them. It was amazing. Usually Microsoft can't resist doing their own thing to it, but in this case it was really high fidelity copy. Now they couldn't call it JavaScript because it turned out Sun claimed ownership of the JavaScript trademark, even though they had nothing to do with the invention of the language, just because they thought they owned everything with the word Java in it. At the time they were shaking down coffee companies. This is true. So Microsoft called it JScript. And so then Netscape was alarmed. Oh no, we're going to get embraced and extended. So they decided we need to make a standard so Microsoft can't run off with it. So they went to W3C and said, please make this a standard. Now it turns out W3C had been waiting a long time for an opportunity to tell Netscape to go to hell. So they did. So that's why this language is not a W3C standard, which it really should have been. So they went shopping around for another place. They considered ISO. Eventually it landed at the European Computer Manufacturers Association, which is a long way to go for a California software company. And ECMA said, okay, we'll do the standard. So they put together a committee. Microsoft joined the committee, and Microsoft dominated the committee. And one of the things they contended was all of those errors and mistakes and design defects stay in the language. At that time, Brendan wanted to fix things. Like he knew he screwed up double equal. He wanted to fix it. Microsoft said no. So all of that stuff got baked into the standard in a wrong way. The other bit of business was they couldn't call the standard JavaScript because that was a Sun trademark. So the committee also kicked around other names like WebScript and NetScript, couldn't agree. So they published it with the working title, which was ECMAScript, which is maybe the stupidest name ever put on a programming language. So that goes along. And then in 2000, George Colony, who's the head of Forrester Research, predicts the end of the web. He says another software technology will come along, kill off the web just as it killed news, go for it all. And that judgment day will arrive very soon in the next 2 to 3 years, not in 25 years. This is no longer on Forrester's website, but you can find it on archive.com or archive.org, so it's still out there. And a lot of people believed this. They thought the X-Internet is coming, it's going to replace the web. Microsoft disbanded the IE team because the web was finished, and they put them to work on what they thought was going to replace it. But it didn't die. The web continued to flourish, and it was because of JavaScript. You know, in a perfect world, JavaScript would have died when Netscape died, because it was essentially a proprietary language. But in fact, the opposite happened. The web survived because it had JavaScript in it. JavaScript saved the web. You know, some people who think, well, of course JavaScript's popular, it's because it's in the browser, forgetting that Java was the first language of the browser. Just being there doesn't guarantee that you're going to win. So JavaScript survives because there's something fundamentally right about it, and that is that it has good parts. And my part in this story is that in 2000, I discovered that JavaScript had good parts. This was the first important discovery of the 21st century. And at the time I announced my results, there was huge skepticism. You know, no way, there couldn't possibly be anything good in JavaScript. But it turns out that it did. So it has statically scoped first-class functions with lexical closure. Best idea in the history of programming languages got into JavaScript first. JavaScript is now an influential language in that there are other languages that are now getting this style of functions based on JavaScript's example. So it's in Python now, it's in Ruby, it's in C#, it's C++ even. Who else now? Is it PHP? Everybody except Java. Turns out Java is having a really tough time keeping up with its stupid little brother. And we have prototypal inheritance, which is a completely different way of thinking about objects, but it turns out it's the right way. And it's much more powerful than the classical model. It's great. The amazing thing about this language is that it can be used by beginners, and it is. Most of the people using the language, I think, could be classified as beginners. And by scientists. There are people who are doing computer science, heavy stuff, functional programming in JavaScript, and everything in between. Now, building a language that satisfies either extreme is really hard. And getting one that does both at the same time and the middle is just astonishing. And it's an amazing achievement. Now, the first JavaScript engines were all optimized for time to market and then got cruftier and cruftier over the years, so they're really slow. So there's a lot of concern about the speed of JavaScript. But it turns out in web applications, it does not matter. This is Microsoft's data on how the top Alexa 100 spend their time. And JavaScript is only 3%. So if you could go and tweak your programs and make them go really, really fast, no one would notice. It's all of the time is being spent in the DOM API. So if you're worrying about speeding up your code, unrolling loops or doing that kind of stuff, you're just literally wasting your time. Now, despite that, the JavaScript engines are now getting a lot faster. Google started things off with the V8 project, which grew out of work that was done on Self, which was another of JavaScript's inspirations. And there's a race now. All the engines are trying to be faster than each other, which is great. It doesn't help the web at all, but it allows for JavaScript to now get into other applications that maybe weren't viable before. So JavaScript's reach begins to grow. And as a result, it's everywhere now. JavaScript is everywhere. It's obviously in the browser. It's found its way into operating systems. It's in the best databases now. You can do work in the database with JavaScript. We're now seeing servers being built out of JavaScript. It is by far the most common language in the mobile world. There's no other language that can reach as many devices as JavaScript can. And it's even finding its way into televisions, which I think is stupid, because you know that this stuff goes obsolete really fast, but you generally want a TV to last 10 or 20 years. So I don't think it makes any sense to put high obsolescence gear into a display, but it's there. You can buy JavaScript TV sets. But there's more stuff coming, which is going to make the language even faster. We're looking at high-performance data structures to go into the next edition of JavaScript, which will allow you to take packaged data and push it down directly into the GPU. So you've now got an extremely fast interface down to the graphics hardware. So JavaScript now becomes viable for doing 3D applications. Really, really neat stuff. And we're looking at some research which might get incorporated into the edition that comes after that, in which we'll have a kind of parallel array structure where you can take a JavaScript function and say, execute this function on each of the members of this array all at once on every core that's available. When we get that, JavaScript will become the world's fastest programming language. That's pretty neat. That we'll be able to do multi-core, highly parallel programming in the same language. Nobody else can do that. We're also seeing work in turning JavaScript into a secure programming language. There was Google's work on Kaha. There was my own work on AdSafe, which make it possible to take third-party code and have it run safely in a browser and not be able to corrupt the page it's in. There's further research at Google on distributed, reliable, secure ECMAScript, which takes this stuff but pushes it into the cloud domain, which is really, really interesting. So we can build secure distributed systems in JavaScript. The biggest surprise is that JavaScript has become the virtual machine. We always thought that the JVM was going to be the world's virtual machine, but it turns out it's JavaScript. Google translates Java into JavaScript so that it can run everywhere. It's amazing. We never thought this was going to become one of JavaScript's most important roles. Yeah, so GWT or the Google WAT toolkit, I don't know why you'd want to do that, because it turns out JavaScript is actually the superior language, but there are a lot of people who really don't want to have to learn it, so it's popular and it runs everywhere. This is a really cool thing that was done at Princeton. They wanted to have a JavaScript virtual machine that was written in JavaScript, and they wanted that so they could test the properties of programs. So they took SpiderMonkey, which is Mozilla's implementation of the JavaScript engine, and it's written in C++. They passed that through CLang, which produces an LLVM file. They passed that through Inscription, which converts the LLVM file into JavaScript, really awful JavaScript, but it's legal and it runs. And they passed that through Google's Closure compiler, which takes that really awful JavaScript and turns it into not too bad JavaScript. And then they've got JS.js. They've got something that's using a native sensibility as to how to build a virtual machine, except it's all running in JavaScript, and it required no work at all. It's just amazing. We're seeing lots of new languages being designed now using JavaScript as their virtual machine. Because it turns out the easy part of designing a language is figuring out the syntax. Actually implementing it and generating code and producing all the support for it, that's actually work. You don't have to do that work now. You just generate JavaScript and you're done. It turns out it's much easier to generate code for JavaScript than it is to generate code for the JVM. So we're doing it. So we've got hundreds of new languages popping up all the time, written specifically for JavaScript. Even more amazing, old languages are now finding their way into JavaScript. We already talked about Java and C, but all these other languages are being translated too. So it's going everywhere. You don't need any of these languages anymore. They all turn into JavaScript. Now this puts some pressure on the evolution of the language, which is sort of interesting. Like there's a desire for the language designers to have go-to in the language. JavaScript has a small set of control structures. And if you have a language that has very different kinds of control structures, it's difficult to map them onto JavaScripts. So you'd like it to be more like a machine language and have jumps so you can synthesize your own. So there's been request to add goto to JavaScript. But many, many years ago, a Dutch computer scientist determined that goto was harmful, and he was right. But even after we learned he was right, it took us a generation to get rid of it. Basically, we had to wait for all these stupid old programmers to retire or die, and then we could look around and say, okay, can we get rid of the goto now? Oh, good. Because there are all these arguments about, well, yeah, it can make your code messy, but sometimes it's so important and it's so useful and it sometimes makes performance better. And it turned out those were all stupid arguments, that it was just a bad thing that we should get rid of. And we finally did. And if we put it back into the language, we know for certain there are going to be idiot web developers who are going to go, oh, you can make your programs go really fast if you use the goto. And then we're going to be stuck with it. We're going to have to wait for them to die before we can get rid of it again. So we're not going to do that. But we are looking at things like proper tail calls, which were initially motivated for doing tail recursion, but also allow for goto-like behavior in languages without the problems that goto is associated with. What it does is if the last thing a function does is return the result of calling another function, that call return sequence gets turned into a jump. And that introduces whole new paradigms of programming, which are really amazing. So that's going to be in the next edition of the language. I'm really looking forward to that. So JavaScript is becoming the world's most important programming language. I mean, what a surprise. From Java's stupid little brother, the language that couldn't do anything right, what I once called the stupidest thing I've ever seen, is turning out to be the world's most important programming language. Astonishing. So until next time, don't forget your semicolons. Thank you and good night. So do we have time for questions? Okay, we're going to do some questions. And there's a microphone here. I guess you're going to run it, or should they just shout? Okay, so any questions?
No one wants to be the first brave one? Go for it, though. All right, I got one. Do you have any opinions about JavaScript? No, just kidding. I love the clear statements of that's just the wrong way to do it. Do you, on most of those statements, do you say that because you believe that fervently, or you have evidence?
Well, I have evidence. My opinions of JavaScript have changed radically over the last 10 years or so. And the thing that changed my mind about JavaScript was JS.lint. In trying to figure out how to statically verify JavaScript programs, which turns out to be important because the language is so flimsy, it's really easy to go off a cliff. JS.lint showed me that all of my preconceptions about what good style was wrong. And so it's been teaching me over the years, painfully sometimes, what the good patterns are and why they're good patterns. So it's not just opinion. I'm not trying to force my views on anybody. It's just that JS.lint showed me that this is what we can actually determine programmatically, and this clearly has benefit over forms which cannot be verified.
I'm going to do another one if you don't come up with one. All right. You listed old languages, and you listed Ruby and Python. I'm sure there was more, but I didn't get them down. Really?
Really, yeah.
How so?
I don't know. I don't know why people would do that, but they're doing it. There exist translators for, at least one translator for each of those.
Oh, no, not about the translators, but you called them an old language just by clearing that. I mean, JavaScript's older than Ruby.
I mean in the sense of people designing new languages specifically to compile into JavaScript, or taking existing languages and compiling them. That's what I meant by old language.
Okay, gotcha. Yeah. So you didn't mean it in the sense of degrading in any means.
No insult was intended.
Hi. As the discoverer of JSON, I'm interested in your answer to this question. I've been writing some languages on top of JavaScript, and you said the easy part of doing languages was the syntax, but if you do a radically different syntax, then there's a bunch of work you have to do. So I've just been using JSON as the syntax for these other languages on top. Mm-hmm. Is that the right thing to do, or am I doing something wrong?
That makes a lot of sense. There are a lot of DSLs which can be made trivially just by, and I think the right pronunciation is JSON. But yeah, you can trivially, one of the inspirations for JSON was S expressions, which was something that came out of Lisp, where Lisp uses exactly the same conventions to express programs as data. And yeah, you discovered the same thing. It's brilliant.
That must feel good. Anybody else?
What do you think about the new class definition in ECMAScript 6?
Yeah, what do I think about that? I think it's a waste of time. It's beneficial for people who want to be practicing the class model in JavaScript, but the prototypal model and the functional model are so much more expressive. You'll just never learn the language well. Now, it turns out JavaScript is so powerful, you can program it the wrong way and still it works. And the new class syntax will make it easier to do that. And so it's going to be a very popular new feature, but it's not one that I'm going to use.
Is it going to be in there, though?
I'm sorry?
Is it definitely going to be in?
I wouldn't say definitely anything because we have not taken the final votes on the stuff. We're hoping to have the next edition ratified by the ECMA General Assembly a year from now. But the feature set that we're considering is so huge, and there's so many steps we have to take through the formal process before we get to the end. I'm not confident we're going to make that deadline. I am confident that if we don't pare down the number of features we're adding, we're probably going to be introducing a lot more bad parts than we intend. But that's how it goes.
Just one more question.
What parts of the ECMAScript 6 spec are you excited about?
My favorite thing is proper tail calls, because that allows us to do continuation passing style and some other things. That's going to be great. My second favorite feature is splat, the ... operator, because it completely, the way we do erratic functions in JavaScript currently is with the argument pseudo array, which is so horrendously painful and stupid. And the new ... thing is so elegant and sweet and nice. I like that a lot. So those are the two main things. Modules is probably also important. It's going to give us some new security boundaries, which are going to be useful and some convenience. And there's a new templating system, which is very different than any templating system you've ever seen, but it'll be native to the language. And so, especially if you're doing server-side stuff, being able to do it in the native language will be really nice.
Thank you very much, Douglas. Everybody? And we're going to move on to the rest of the presentation. I want to remind you that the next coffee break, get this out and get a shirt like this. Isn't it nice? And at the second coffee break of the day, we'll be coming back here right after that for another follow-up keynote from Mozilla, I believe, and then the roundtable discussion. And please do go to that website and ask questions. You can also find me if you want and go, I want to ask about this, and I'll try to get that in there if it seems good. So let's get on to the next sessions. And there are some great sessions